Hello everyone. Hello everyone and I welcome you all on Unacademy JEE English guys. This is a channel launched by Unacademy. On this channel guys, we are going to teach you each and every concept of ITJ in pure English. And today I am Rahul Kaushik. I am going to take lecture number 2 of chemical equilibrium. So guys, today I will be covering lecture number 2 and I will be taking law of mass action. It's very important because law of mass action, you will also study this law of mass action in your 12th class in chemical kinetics. But this law of mass action was given by Goldberg and Wajid, and that law of mass action is different. So guys, today I am going to take law of mass action of chemical equilibrium, and that's very important guys. That's very important. So before I proceed ahead guys, first of all let me introduce you. I'm Rahul Kaushik and I worked in Bansa classes Kota. Yes, Kota, everyone knows it. Hi Satija, hi Amy, hi Keshav. Yes, I'm here, Keshav, I'm live. So guys, I worked in Bansa classes Kota since 2010 to 2020. So continue 10 years I worked there guys. And after that guys, I co-founded my own organization, that is Zigyan Education Private Limited. Now along with Zigyan, I'm here on Unacademy, India's largest and fastest growing online platform, to share all my experience and knowledge with you guys. Good afternoon, Monagi. Good afternoon. Yes, you are back, I can see. And guys, during my tenure in Bansa Classes Kota, I mentored almost 2000 plus IITs, guys, including many top rankers. And I was head of department there for chemistry, guys. And now I'm here on Unacademy. So, guys, this is a new initiative by Unacademy. And as you can see on this channel, guys, each and every topic is taught in pure English. Hi, VD. And this JEE English, this JEE English is the name of the channel guys. We are there on the Telegram, and JEE English, this is also good afternoon Keshav. This is also our channel on Telegram guys, and the link for this channel is given. You can join this channel because on this channel you will get latest notifications of our lectures. Sir, daily time waste introducing. Please upload one introduction clip before starting live. Okay, I will follow it. Okay, Sajja, definitely we can do it. Yes, now this has become, yes, a daily routine. Daily I have to introduce myself because there might be new students. So I have to do this, but your idea is good. We can have a clip for that. And the same thing we can repeat. Yeah, yeah. I will think over that. So guys, now I will tell you some simple steps how you can subscribe to an Academy Plus. Because guys, on YouTube, we are providing you the video lectures. Video lectures are very important, but along with video lectures, when you are preparing yourself for IIT, JEE or any competitive examination, you have to practice. And in order to practice guys, you should have modules, you should have daily practice problems. So after every class, you should have all these things, right? And on the plus we provide all those things, because on the plus guys, every fourth class will be a doubt clearing session. After every class we provide modules guys, dpps are there, sheets are there, and module dpp sheet, then we will have weekly quiz, live quizzes there, then we will have mega quiz after completion of every topic guys. So there are so many things, and other than this guys, you will have access to not just my video lectures but the video lecture and content of all the educators. And then guys, install it. I don't know what is the meaning of vd. I think vd can tell you only. Only vd can tell you. So guys, here once you are clicking on the plus, so on clicking plus you will be getting IIT JEE and NEET UG. So just check the IIT JEE box, and once you are checking it guys, hit the subscription button, and after hitting it guys, you will be reaching here. And here guys, for 24 months, if you are applying my code, just remember this code guys, because the fee structure is like it. For 1 year you have to pay 38,000, for 2 year you have to pay 56,000. But if you are applying this code, just note it down guys, this is also important, then you will be getting a flat discount of 10%. Instead of 38 you have to pay 34. Instead of 56 you have to pay almost 50. So guys, remember this code Rahul Chem, Rahul my name, Chem chemistry. So I think this code can help you in getting a huge discount, 10%. So guys, this is all I can tell you about the plus. These are all the benefits. So guys, now tell me, are you ready for today's class? Are you ready for today's session, guys? Yes, I can't see you're ready, your thumbs up or okay or yes on the chat box. Are you ready, guys? Shall we begin now? Tell me, guys. Okay. So guys, now let's start law of mass action. Now let's start law of mass action. So I was telling you about this spoon, and this spoon is containing sugar. When you are adding the sugar, guys, what will happen? The sugar will dissolve throughout the water, and once this water becomes saturated, I call it an equilibrium has been achieved, at which rate of dissolution become rate of crystallization. So equilibrium is not something which you only study in your chemistry. So guys, it is something which comes in daily life as well. So we were discussing that equilibrium is not dynamic, equilibrium is not static in nature, it is dynamic, guys. And if equilibrium is dynamic, means it never stops, just the rate of forward reaction become equal to rate of backward reaction. I think guys now you got it what I'm saying. So these were some examples which I took in yesterday's class. These were some examples. Okay guys, so here I'm taking this chemical equilibrium. Got it? So now guys, these were all examples of chemical equilibrium. Here I was telling you like N2O4, this is NO2. So as N2O4 is decomposing into NO2, this color is becoming darker and darker. And finally, an equilibrium has been achieved at which the rate of dissociation or decomposition of N2O4 is equal to rate of formation of NO2. Got it, guys? So these are all the things, guys, which we have covered in the last class. Okay. So guys, now I will start. But before starting, guys, let's do one thing now. Yes. Identify. Write down one question, guys. Identify correct graphs for equilibrium. So guys, identify the correct graphs for equilibrium. Which graphs are correct at equilibrium? Suppose I am taking this as reactant and it is converting into product. At t is equal to 0, suppose guys a molar was there and it was 0. And once your equilibrium is achieved, suppose this is a minus x and this is x. So now what will happen, guys? So now let's make graph. Now let's make it. So guys, if I'm telling you this is rate versus time, right? Yes, Sarath, I will teach inorganic and physical. I will not teach you organic. Then I will take here concentration and time. So guys, tell me which graph is correct here. So if rate versus time, or initially let me take concentration versus time only. So this is concentration of R. This square bracket represent concentration. When I am writing this, it means molarity of R in square bracket. So always remember it. In square bracket, if something is written, it means it is molarity, or I generally call it concentration. Okay, guys. So tell me which of the following graph is correct for the concentration. This is concentration of R. Got it? And here we can have one more graph. This is concentration of R. This is concentration of P. This is concentration. This is time. Now tell me, guys. Yes. Out of these three graphs, which of the following graphs are correct? Which of the following graphs are correct? 1, 2, 3, or all? So, guys, this is the time at which equilibrium has been achieved. This is the time at which equilibrium has been achieved. Yes, guys, tell me now. Which of the following graph is correct? Anyone, guys? Is it first one, second one, or third one? Because in last class I told you the characteristics of equilibrium. At equilibrium, whatever I told you, guys, tell me which of the following. Identify the correct graphs, guys. I'm waiting for your answers. Let me give some names. 1, 2, and 3. Which one is correct? Norman says third is correct. Okay. Yes. Is there anyone else? Alice says all are correct. Okay. Yes. Anyone else, guys? Okay. So, guys, now I will tell you. Now I will tell you. No, after this, you can download this content, whatever I'm teaching you, the video lectures. So here, all three are correct, guys. Here, all three are correct. 1, 2, and 3. Everything is correct, guys. So Alice was correct. And no, man, you are not right this time. So, guys, at equilibrium, I told you that concentration of reactant and product become constant. I never told you that concentration will become equal. I never told you. So when equilibrium is achieved, then concentration of reactant and product will become equal. Sorry, constant, not equal. Yes, it can be equal, but if it is not equal and it is constant, then it is okay. It is equilibrium, right? So, guys, now I'm moving on to the next point. Yes. Now this is the rate of forward reaction. This is the rate of backward reaction. Examples I will give you. Don't worry. So, guys, this is 1, this is 2, this is 3. So here I was taking concentration, but now here I will take rate. So this is rate of forward reaction. This is rate of backward reaction, right? This is time. So this is the time at which equilibrium might have been achieved. Now, if I'm making these graphs, then, guys, identify the correct graph. Identify the correct graph, guys. Which one is correct here? Which one is correct? Don't worry, Shaitaja, I will be taking the problems. You can see here. I'm taking all the conceptual problems. Because we can upload on YouTube, we can upload only one file. Yes, guys, do it. Tell me, guys. So, guys, at equilibrium, I tell you that rate of forward reaction will become equal to rate of backward. In this case, if I assume here equilibrium has been achieved at this point, rate of forward and backward both are equal. Forward rate is decreasing. Yes, from this reaction you can see. And this is the backward. So initially there was no P. There was no product. So backward reaction rate was 0. But slowly it is increasing. But rate of forward should be equal to rate of backward when equilibrium has been achieved, guys. So this will be your answer. This will be your answer. This time this is incorrect and this is correct, guys. This one is correct. So at equilibrium, concentration may or may not be equal. it should be constant. What is the definition of equilibrium, guys? At equilibrium, various properties, measurable properties like concentration, partial pressure, temperature, etc., these become constant and does not change with time. And at equilibrium, rate of forward reaction become equal to rate of backward, and here it is not equal. If I'm saying this is equilibrium, this rate is not equal, and even this graph is wrong. Okay, guys, so now there is one more point which I want to discuss now, and that point is, yes, if I'm making the graph between concentration and time, okay, if I'm making it, guys, so suppose this is the concentration of product, this is the concentration of reactant, got it? So now what I'm doing is, now I'm using the catalyst. Now what catalyst will do? So this is the concentration of product at equilibrium. This is the concentration of reactant at equilibrium, right? Now if we are doing it, guys, what will happen now? If I'm using the catalyst, then yes, this will be the graph. So if you have observed it, guys, I'm writing it. This is uncatalyzed, and this one is catalyzed. So guys, what do you mean by catalyzed reaction? In a catalyzed reaction, you have used catalyst, and in the last class, guys, I told you that if you are using the catalyst, it will not affect equilibrium concentration. It will not affect equilibrium concentration. It will help in achieving equilibrium. Suppose initially your equilibrium was achieved after 30 minutes. So guys, now it can be achieved in 10 minutes only. Got it? So it will help in achieving equilibrium quickly. Got it, guys? So this is example of catalyzed and uncatalyzed. So catalyst will help in achieving equilibrium quickly. It will increase the rate of forward as well as backward reaction to the same extent, but it will not affect the concentration of reactant and product at equilibrium, because here, guys, you can say the concentration at equilibrium, the initial concentration at equilibrium is same as the final concentration, because in both cases the concentration of R is same. But when you are using the catalyst, initially your equilibrium, you achieved the equilibrium in 30 minutes, now you are achieving it in 10 minutes, and there is no other difference, guys. Got it? Tell me, guys, if you have any doubt. No doubt. So guys, this was the effect of catalyst. So guys, this was just a small question or quiz in which I wanted to ask how many of you have understood what I have taught you in the last class. So now I'm moving on to the next part, guys, and this is the law of mass action. This is the law of mass action, guys. Note it down. It was given by Goldberg and Vajay, because I told you there will be one more law of mass action and you will be studying it in your 12th class in chemical kinetics. So what is law of mass action? So in this case, guys, this is A and B, these are C and D. So when A and B are reacting with C and D, what is going on, guys? What is going on? So when A and B are reacting, after some time, suppose at T is equal to 0, you are taking, this is A mole, and here you are taking B moles. Initially it was 0. So what will happen, guys, after some time? Maybe after some time it will be A minus X, B minus X, it will be X and X. Are you getting it? So at equilibrium, what will happen, guys? So Goldberg and Vajay, what they told about the equilibrium? Do you have any idea about it? Yes, what they told about the equilibrium. So guys, now I will tell you, at equilibrium, this is rate of forward, this is rate of backward. So rate of forward reaction rate of forward reaction is directly proportional to activity of A raised to the power A, activity of B raised to the power B. Now guys, these are new terms for you. What is activity of A and what is activity of B? So guys, we will replace these activities with those terms which are part of your syllabus. Activities are not part of your syllabus, guys. Okay? Yes, activities are not part of your syllabus. So we will replace these terms, guys. So don't worry about it. Okay? So guys, now I'm moving ahead. Then rate of forward, this is RF. So RF I can write KF into activity of A, activity of B. Similarly guys, rate of backward reaction, so RB is equal to AC AD. So RB will be equal to KB into AC and AD. I hope guys you got it now. So C and D are concentration. Now I will just write it. So at equilibrium, what will happen guys? At equilibrium, what will happen? Tell me. So at equilibrium guys, rate of forward reaction will be equal to rate of backward. And when you are writing it guys, rate of forward is equal to rate of backward, then what does it mean? What does it mean? Tell me. So guys, in that case, I can write Kf into A raised to the power A, B raised to the power B, KB, C, D. So guys, here you can write Kf over Kv will be equal to AC, AD, AA and AB. Right guys? So this is equal to equilibrium constant. So guys, we have got this expression and now you should know the meaning of it. What is the meaning of it? There is some lag guys, let me check it. Just a minute guys, I have to stop it for a moment. Guys, just so I hope now it will improve. So there was some lag and even I was feeling that. Yes, I mean, is it okay now or you are still feeling the lag? Just a minute, let me check it. Now I think now it is okay. Okay, I have to, now I'm back and I hope now problem has been sorted out. Yes, now it's working fine. Okay guys, so let's start now. So guys, this is called equilibrium constant. As you can see it, just note it down. What are the meanings of all these things guys? Just note them now. So here guys, K equilibrium, we call it equilibrium constant. Okay guys, we call it equilibrium constant. Kf and Kb, these are called rate constants for forward and backward reactions respectively. Right guys, I hope now you got it. And guys, note it down each and everything guys, that's important. And what are AA, AB, AC and AD? These are active masses of A, B, C and D respectively. These are active masses of A, B, C and D respectively. Note them down guys. Got it? So what do you mean by active mass? So guys, active masses are something which are not part of your syllabus. So we will replace the active masses with those terms which are part of your syllabus. Note it down guys. So we can replace them. We can easily replace them. Okay guys. So now let's take case 1. Case 1. So guys, C, A, B, C, D, these are coefficients. So guys, always differentiate between these two terms. Like K equilibrium is different from KF and KB. Note it down. KF and KB, these are called rate constant for forward and backward reactions respectively. Right? Partial marking means, yes, suppose you have three or four options A, B, C, D, and three are correct A, B, and C, and you marked A and B. So you will be getting mark for this. Otherwise, in multi-correct, if answer is A, B, C, and you are marking only A and B, so you will not get anything if partial marking is not there. So partial marking is beneficial for students, especially if out of three options you are sure about two, then you will get marks. Okay, Triveni. So now, guys, case 1. So for liquid solutions, for liquid solutions, active masses are replaced by concentration. Right? For liquid solutions, guys, active masses are replaced by concentration. And how will you do this? So concentration, guys, I'm talking about concentration. So instead of active mass of C and active mass of D, instead of active mass of A and active mass of B, guys, there I will write K equilibrium will be equal to concentration of C, concentration of D, concentration of A, concentration of B, C, D, A and B. I hope guys you got it. I hope you got it, guys. And guys, this equilibrium constant, we call it Kc. And guys, here C represent concentration. Note it down. So K equilibrium, I can write K equilibrium as Kc, and C represents equilibrium concentration. C represent concentration here. So guys, now I will talk about Kc, case 2. Now I will talk about case 2, guys. So what is case 2 here? What is case 2? So for gaseous components, yes guys, for gaseous components, active masses, note it down, active masses can be replaced by either partial pressure or concentration. Why guys? Because in case of gas, we can also determine their partial pressure as well as concentration. So guys, if we are doing it, then how can I write it? So Kp I can write partial pressure of C, partial pressure of D, partial pressure of A, partial pressure of B. Got it? This is Kp, guys. Similarly, if you want to write Kc, then it will be same. Concentration of C, concentration of D, concentration of A, concentration of B. Why? Because in case of gases, you can determine their concentration as well. But in case of liquid solutions, you can only determine their concentrations, because for gases, no partial pressure is there. So how will you determine the concentration for gas? Okay, let me tell you this thing as well. So guys, suppose here I am taking a vessel of volume V liter. Right. Here I am taking a vessel of volume 10 liter. Now suppose 2 mole of gas are there. So what will be the, and A gas is there. So what will be the concentration of it? So moles of A upon volume. So there are 2 mole divided by 10. So 0.2 molar solution is this. So in case of gases, you have to divide the volume of by volume of container. So moles upon volume, you will be getting the molarity, guys. You will be getting the molarity. Now I'm moving next. Now I'm moving next, guys. Case number 3. Case number 3. In case of pure solids, pure liquids, in case of pure solids, pure liquids, and excess solvent, we take their active masses as unity. Right, guys? So what exactly I'm saying is, suppose here if I'm writing A solid, B aqueous, giving you C aqueous and D liquid. Suppose something happening like it. So this is pure solid, this is pure liquid. So guys, how can I write it? How can I write it? Can anybody tell me? So I will write here Kc will be equal to, this is aqueous, so I will write it concentration of C. I will write it concentration of B, guys. Now this is pure liquid, this is pure solid. Got it? Yes. Anything you want to ask now? Tell me, guys. Anything? Nothing? So guys, now this is Kc, concentration of C and concentration of B. Tell me. So I'm not writing pure liquid and solid. If I'm writing them, it will be unity only. So concentration will be like it. So now you can write some expressions for it. And how will you write it? Now let me take one example for this, guys. Suppose I'm writing H2O liquid and it is getting converted into H2O gas. Right, guys? So write the expression for Kb. So expression for Kb will be partial pressure of H2O. And guys, there is one more point which I want to tell you here. Yes, and that point is, guys, yes, these are the concentrations at equilibrium. When I'm writing equilibrium expression, the concentrations of reactant and product I'm taking, it is A, B, C, and D. Then, guys, those concentrations are basically concentrations of those reactant and product at equilibrium. If I'm taking the partial pressure, guys, it will also be at equilibrium. If I'm talking about partial pressures, then it will also be at equilibrium. So here you can write. Any doubt, guys? Any doubt you want to ask? Tell me. Any doubt you want to ask, guys? No doubt. So guys, here I'm telling you, if there is pure liquid or gas, then you can find it. Tell me, guys, if you have any doubt. No doubts. So because here we are having pure liquid, so just tell me one more, write the expression for Kc. I'm taking one more case. CH3COH aqueous, H2O liquid, and it is giving you, yes guys, can you find the expression for Kc? Just write it down, guys. Do it. After this we can plan that. After chemical equilibrium we can take atomic structure or chemical bonding. So what is Kc here? So Kc here will be, you will be writing the expression like it. This is aqueous, this is aqueous, and then this. Got it, guys? Any doubt you want to ask? No doubt. Is that done now? Yes. Now because here H2O is solvent, So you have to take its active mass or its concentration as unit. Actually, it is not concentration, otherwise we cannot take concentration of pure water as unit. It is active mass. So we can take. Yes, Amy, you are right. Very good. Very good, Amy. So now let's move ahead, guys. Now let's move ahead. So let me take one more example for it. If I'm writing NH3 aqueous, it is giving me okay. So now no, find the Kc. Tell me, guys. Find the Kc. So it will be concentration of NH4 OH minus. Yes, tell me. Tell me, guys. Now you have written. Now you know how to write the equilibrium expressions, guys. Okay. Now every one of you should know how to write equilibrium expressions. Got it? So guys, now let's move to the next point. Now law of mass action is over. Now write down the equilibrium expression for each. Like calculate equilibrium expression of Kp for it, Kc for it, Kc for it. Yes guys, be quick. Now write down the expressions for it. Write it down. So in this case guys, everything is gas. Write down the equilibrium expression for this. So here you can write partial pressure of O2 into partial pressure of H2O, partial pressure of H2O2. Got it? And what is Kc guys? Concentration of O2, concentration of H2O2 square. Okay guys, square. And here you will write concentration of H2O square. Square. Okay. And for this, how will you write? The Kp will be partial pressure of PCl5, partial pressure of chlorine, partial pressure of PCl3, and Kc will be concentration of PCl5, concentration of PCl3, and concentration of Cl2. So you got the value of Kc and Kp. Now I will take the Kp and Kc for next one. For this one guys, how will you do this? For this one, Kp will be partial pressure of CO square. 2 is there. And what is Kc guys? So Kc will be concentration of CO. Got it? Now the next case guys. Next case. Now the Kp will be partial pressure of H2S, partial pressure of H2, and this is solid guys, you don't have to write it. And what is Kc here? Concentration of H2S and concentration of H2. Got it? Yes, tell me guys. Done? Any doubt? So let's do the calculation for it. Write equilibrium expressions for it as well. For these reactions guys. Write down. For this. If you are writing it, then Kp will be 4. And what will be the value of Kp for it, guys? What will be the value of Kc? It will be concentration of high nega NiCO4. So if you are attending it, yes, you will be learning, because in NEET the level is low and I am preparing you for IIT JEE Advanced. So I don't think you will face any issues in it. So here you will write concentration of CO raised to the power 4. Done. Now do this one. Kp not defined. Yes. Why, guys? Why it is not defined? Tell me. Why this Kp is not defined here? Because here everything is liquid. So I can just write Kc here, and Kc will be concentration of F minus H3O plus and HF. This will be unity, guys. This will be unity. Got it? Now what is Kp for it? Yes. Again, this is aqueous. So guys, here you have gas as well as aqueous. So in this case, what we will do? Yes, this is a typical case, and many a times I see that students are not able to solve it. So guys, for this we define a new term, that is KPC. P for pressure and C for concentration. So for aqueous I will write chloride. This is pure bromine, so you don't have to write anything. And here I will write Br minus. And in this case, guys, I will write partial pressure of Cl2. Yes. So here I have merged P and C both. Here I have merged P and C both. So if gas as well as liquid is present, guys, in that case you have to define Kpc. This is also equilibrium constant. Got it, guys? Tell me if you have any doubt. Any doubt, guys? No doubt. So guys, now let's move to the next point. What are units of K here? What are units of it? If I'm writing this reaction A giving you B, so what will be the unit of equilibrium constant? So guys, suppose I'm writing Kc, it will be concentration of B over concentration of A, right? So units of K, tell me guys, what will be the units of K? So units of K in this case, hi Osho. So units of K in this case will depend upon the values of A and B, and these are called stoichiometric coefficient. So if I'm writing it, yes, Kc will be, if I'm writing it molar, because concentration will be expressed in molar. So guys, unit will be molarity into B minus A. So if A is equal to B, then Kc will be unitless. So it can be unitless or it cannot be unitless. Actually, that will depend upon the values of A and B. Yes, also I'm taking that 8 p.m. today. Today 8 p.m. I'm taking that session. Okay, Osho. Yes, JEE Advanced I'm going to discuss that. So guys, today 8 p.m. I will be discussing JEE Advanced. Note that down. Now next point. Similarly, if you want to write Kp, so it will be partial pressure of B, it will be partial pressure of, so it is B, it is A, right? So now you know what is B, what is A. Now you know that. So guys, again it will be ATM raised to the power B minus, right? Note it down. So from here guys, we can say units of Kb and Kc depends on Units of Kp and Kc depend on stoichiometry of reaction. Note it down. Units of Kp and Kc depends upon stoichiometric coefficient. Got it, guys? So units of Kp and Kp are not fixed. For every reaction, they will have different value. Yes, Nega, you can attend it, and if you are regularly attending it, following it, you will definitely learn. Sir, this lecture cover all NCRT point because this year the NEET equilibrium question directly from NCRT solved question. Only value is different. Yes, definitely you can match it. So I'm covering each and every point of NCRT and then I'm moving to the higher level. So I don't think you have to worry about it. Okay, I don't think so. I hope you got it now. Okay, guys. So now let's move to the next point, guys. What is the relationship between Kp and Kc? So if here I'm writing AA giving me BB, right? So if suppose this reaction is taking place in a container and inside that container you have A as well as B, right? So what is Kp, guys? It is partial pressure of B and partial pressure of A. And what is Kc here? It is concentration of B and concentration of A, B and A. Okay, guys. So guys, suppose this is the volume V of this container and A and B both are present in it. So if I say partial pressure of A will be mole of A RT by V. So I can write it as concentration of A into RT because moles of A by volume. Similarly, the partial pressure of B, I can write concentration of B into RT. So once you are doing it, guys, so PB upon PA. What is PB? It is concentration of B. So guys, it will be concentration of B, concentration of A into RT B minus. Got it? So guys, KB will be equal to KC and RT raised to the power delta Ng. RT raised to the power delta Ng. Got it? Any doubt? So now I'm moving. Yes, Nega, what are you saying, sir? Take any out of NCRT. I'm not getting your point. Any out of NCRT? Teach any out of NCRT. So guys, let's see now. Kp and Kc, and now guys, what is delta Ng, guys? So delta Ng will be moles of gaseous product minus moles of gaseous reactant. So note it down, this is B, this is A, and it should be gaseous only. You don't have to consider the moles of liquid and solid. Why? Because we apply this formula only for gases. So if liquid and solid is there, then you don't have to take it. Okay, guys. Got it? So guys, now it is clear the relationship. So tell me if I'm writing something like it. PCl5 gas giving you PCl3 gas plus Cl2 gas. So tell me what will be the value of delta Ng for it. So everything is gas here. It will be 1, 1, minus 1. So what will you be getting? Plus 1. Got it? Similarly, if I'm giving you one more problem, and that problem is CaCO3 solid. Suppose it is giving you CO solid, CO2 gas. Now, what will be the value of delta Ng? Again, this is 1. Again, this is solid, so you don't have to take their moles. Plus 1. Yes, KKS. I will discuss that point after this class, guys. I am taking 8 p.m. today discussion of today's exam, and then I will be discussing. Don't worry, KKS. Currently, I cannot say anything about it. I will see the paper because since morning I am taking classes, and I will get some time after this class, and once I look into the paper, only then I can comment. But score is good from advanced perspective. Yes, we take each and every point. Negha, you can follow my previous lectures as well, as because we have covered almost complete 12th class. So you can watch those lectures and you will realize that whatever we are doing, everything is from NCERT, and then we are increasing the level. Even not a single point from NCERT we have missed. You can go through my lectures of solid state, chemical kinetics, liquid solution, anything you want. Okay. So I hope now you got it, what I'm saying. So guys, now I told you what is the meaning of delta Ng here. The relationship is given. So just write down question, write relationship write relationship between Kp and Kc for the following reactions. Yes guys, for this reaction, what will be the relationship between Kp and Kc? No KKS, it's not like that because all concepts are ultimately from NCERT. All concept and everything is ultimately from NCERT. So don't think like it. Surely. Concepts are all from NCERT. There is nothing outside NCERT. Today 8 p.m. I will be discussing it, and surely I will discuss all the things. So guys, in this case, calculate value of delta Ng. So Kb is equal to Kc RT delta Ng. So delta Ng is 0. So Kp will be equal to Kc. Yes, how many of you got it? Tell me guys, how many of you got it? Yes, now calculate delta Ng for it. So Kb will be equal to Kc RT delta Ng. So Kb is equal to Kc, and delta Ng will be -2. I hope you got it guys. Yes, now solve the next problem as well and tell me the exact relationship. Tell me the exact relationship guys. Yes. So in this case, what is the value of delta Ng? +1. Okay, KK, surely I will discuss that point as well. Don't worry about it. I have not seen the paper, Osho. Once I will look at it, and definitely I will answer you. Don't worry about it. I will surely discuss with you guys. Surely everything I am going to discuss with you. Okay? Yes, guys, now do this one. So in this case, delta ng is 1, so Kb is equal to Kc into RT. Got it? Now let's move to the next point. Yes, what about this? So calculate the delta ng here. Calculate the delta ng. 1 plus 0 minus 0. Because these are solid, so you don't have to take their moles. So Kb will be equal to Kc into RT delta ng. So if delta ng is plus 1, so Kb is equal to Kc into RT. Got it, guys? Got it? Any doubt, please ask. No doubt. So just find the relationship between Kp and Kc for it. Find it, guys, quickly. Be fast. Yes, I'm waiting for your answers. Aqueous, aqueous, aqueous. Okay, Osho, I will discuss it today. Don't worry. So what will you get here? What will you get, guys? In this case, guys, everything is aqueous. So Kb is not defined, right? And if Kb is not defined, then why should I talk about it? So I will just write Kc. It will be concentration of I3 minus I minus I2. Any doubt, guys? Any doubt? Yes, also I'm telling you, I've not seen it. Once I will see it, then I will discuss with you guys. Don't worry. Don't worry, Osho. I will be discussing it with you. Now solve it. Yes, guys. Have you done it? Clear? So, guys, now let's move to the next point. Yes. What is Kx and Kpc? So, I've already told you Kx. This x represents mole fraction. So, you can write AA giving you BB. So Kx will be mole fraction of B raised to the power B, mole fraction of A raised to the power A. Done? Got it? So now Kx is done. And if I'm talking about Kpc, now what is it? Okay, Gaurav, I will see to it. Then I will let you know. Yes, what is coming in advance from NCRT. So guys, when I'm talking about KCl, suppose I'm taking HCl gas and I'm mixing it with water and it is giving you H plus aqueous and Cl minus aqueous. So here I am having aqueous, here I am having gas. So in such a scenario, I will define a constant Kpc. Okay, Gaurav. Yes, tell me, Abki Apda. Tell me what happened with you. Then I will discuss it. H plus and chloride. So I will write the concentration of these two, C4 concentration, and I will take the partial pressure of HCl, and always take this partial pressure either in atm or in bar. Never take it in Pascal, because generally these concentrations will be in mole per liter. Okay. Okay. T in bar, but why did you solve a single problem 3 times? Devyans, I'm already taking course on the plus. I have covered the mole concept, and now I'm taking after mole concept I'm taking redox reaction from 1st of October. Yes, Devyans, you can find me there. The course on the redox and equivalent concept I'm going to launch here. Yes, Ryan. Sir, cover chemical equilibrium in chemical process means dynamic equilibrium. I'm not getting your question. So Devyanshi, you can find I've already covered the mole concept. Yes. So guys, now you know the meaning of KPC and KX. I hope you got it, guys. So what is KX? What is KPC? Now guys, there are two more terms, KC naught and KP naught. What are those? Actually, in this case, guys, units of KPC, KP, KC, these will depend upon the stoichiometry of reaction. So now we define two more terms, KC naught and KP naught. So what is KC naught? Let me write here. If KC I am writing, it is concentration of B, concentration of A, B and A. And what is KC naught? So Kc naught, what I am writing, guys, concentration of B divided by 1 molar B, concentration of A divided by 1 molar A. So guys, when I am writing it, it will be, this is Kc naught, it will be a unitless and dimensionless quantity, right? Why? Because if you will write B, suppose you are taking 5 molar upon 1 molar, suppose you are taking 2 molar upon 1 molar. So guys, this one is basically removing this unit. So Kc naught will be unitless. Similarly, yes, similarly guys, if I talk about Kp, so Kp we write partial pressure of B, partial pressure of A. So what is Kp naught? It is partial pressure of B over 1 bar, partial pressure of A over 1 bar. So again, the purpose of 1 bar is it will not change the magnitude, but it will cancel out the units. And I will say that this will be unitless and dimensionless quantity. Okay guys, I hope you got it now. I hope you got it. Tell me, no doubt now. So guys, now let's move to the next point, guys. Now Kp naught is clear, Kc naught is clear. So these are basically magnitude wise, they will be same as Kp and Kc, but these will differ in terms of units. Yes, dynamic equilibrium we covered in the first lecture. I explained, Rayan Faris. Yes, Rayan, I explained in the first lecture as well. Yes, there is a point that equilibrium is dynamic. Why it is dynamic? I have explained that. Got it? Yes, go through my previous lecture. You will find the meaning of dynamic equilibrium and why we call equilibrium dynamic. Surely you will find it there. Okay, Rayan? Yes. If you are attending the lectures, guys, then revise the previous one and attend the complete lecture so that you don't miss anything. So that, guys, you don't miss anything. If you are missing anything, then it will be difficult, right? It will be very difficult. So guys, now Kp and Kc is clear. So now let's talk about homogeneous equilibrium. So guys, what is homogeneous equilibrium? What is homogeneous equilibrium, guys? Can anybody tell me? So note it down, guys. Homogeneous. If all reactants and products, note it down, guys. If all reactants and products are in same phase, then we call it homogeneous equilibrium. For example, and I'm writing 2HI gas. So guys, this is homogeneous equilibrium, right? Hi Tarian. So what will be the Kc for it? Just write down the Kb and Kc. It will be Hi, it will be H2, it will be I2. And what is the Kb for it? Partial pressure of H2, partial pressure of I2. Got it? So now guys, I'm moving on to the next part, PCl5. On dissociation, guys, it will give you PCl3 gas plus Cl2 gas. So now find the value of Kc and Kb. Tell me, guys. Be fast. Find it. Done it. So Kc will be PCl3 and concentration of Cl2 and concentration of PCl5. Got it, guys? What is Kb here? Kb will be partial pressure of PCl3. Got it? Now let's talk about it. Let me take one more example for it. Yes, guys. Again, in this case, all reactant and product are in form of liquid solution. So what it will be, guys? It will be homogeneous because everything is present in form of solution. And if it is homogeneous, guys, so how will you write Kc? Kc, you will write it as over, like this way. Yes, tell me, guys. Any doubt? Got it? So now next point is heterogeneous equilibrium. What do you mean by heterogeneous equilibrium? So in homogeneous, either everything will be in gaseous phase or everything will be in liquid phase, but everything cannot be in solid phase. Otherwise, there will be no equilibrium, right? So guys, now let me take example of heterogeneous. First of all, I have to make you understand what is heterogeneous. Heterogeneous means if reactants and products are present in more than one form, more than one phase, then that equilibrium is called heterogeneous equilibrium. So let me take one example for it, and that example is CaCO3 solid, and it is giving you CaO solid and CO2 gas. So guys, in this case you can find solid and gas. So Kb you can write partial pressure of CO2. Kc you can write concentration of CO2. I hope guys now you got it. So again let me take some more examples of it. 3 Fe solid. So when steam is passed over iron piece, what will happen? It will give you Fe3O4 solid plus 4H2 gas. Now write down the value of Kb for it and write down the value of Kc for it. So Kc will be concentration of H2 raised to the power 4, concentration of H2O raised to the power 4. And what is Kb guys here? It is partial pressure of H24 and partial pressure of. So it is heterogeneous. Why it is heterogeneous? Why it is heterogeneous? Solid gas, solid gas, solid gas. Got it? Please tell me if you have any doubt guys. Please tell me. No doubt. So now you know the meaning of heterogeneous and homogeneous. Got it? If you still have any doubt, please ask me guys. So suppose I am telling you H2O liquid and it is converting into H2O gas. So write down the expression for Kb here. What will be the expression for Kb for this case? Tell me guys. So the Kb will be partial pressure of H2O. And what is this partial pressure of H2O guys? This is the pressure at equilibrium. And guys, when it will change, we call this pressure as vapor pressure. So from here comes the definition of vapor pressure. If somebody asks you what is vapor pressure, so guys, what is vapor pressure? It is the pressure guys exerted by vapors of a liquid. It is the pressure exerted by vapors of a liquid when liquid and its vapors are in equilibrium. So guys, note it down. If somebody asks you what is the vapor pressure, so guys, vapor pressure is again it is the pressure at equilibrium when your liquid and gas are in equilibrium. Suppose here I am taking water. And here some vapors are there. So when rate of evaporation become equal to rate of condensation, here it is evaporation, so here it is condensation. At that moment the pressure exerted by the vapors of water will be known as vapor pressure. Got it guys? So what is vapor pressure guys? It is the pressure exerted by vapors of a liquid when liquid and its vapors are in equilibrium. Note it down guys. So guys, there is one more point, and here I will take that factors affecting equilibrium. Factors affecting equilibrium. So guys, what are those factors which affect equilibrium? Can you tell me? What are those factors? So guys, there are many factors, but the only factor is K equilibrium depends only on temperature. So it can be changed only by changing temperature. It can be changed only by changing temperature, otherwise it will not change. Why I am telling you guys this point? Because your vapor pressure is equal to Kb. So if somebody asks you how can we change the vapor pressure, then your answer should be vapor pressure is equal to Kb, and we can change the Kb only by changing the temperature. So vapor pressure will be changed only when Kb is changed. So guys, vapor pressure of a given liquid can be changed only by changing temperature. Note it down. Vapor pressure of a given liquid can be changed only by changing temperature. Vapor pressure of a given liquid can be changed only by changing temperature. There is no other way, guys. So today I told you what is vapor pressure and how you can change the vapor pressure, and what is equilibrium constant, how many types of equilibrium constant are there. So I told you that in equilibrium constant we have Kp, we have Kc, we have Kx, we have Kpc, but actually these two are called true equilibrium constant. Note it down, guys. And now the factors affecting the equilibrium constant, and I told you that this equilibrium constant depends only on temperature. Okay, guys. So please tell the importance of NCERT text. G1 NCERT textbook is very important because all concept are there. I've been teaching IITians. Yes, I have mentored 2000 plus IITians, guys. I'm telling you, NCERT is very important. All concepts are from it. Right? Today 8 p.m. Today 8 p.m. I will be discussing the paper with you. 2020 advance. So guys, don't miss that. Today 8 p.m. I will be discussing with you, and then I will tell you the importance of NCERT. You cannot simply ignore that. Okay, guys. So guys, this is all about today's class. And if you really like today's class, guys, then please share it and like it as much as you can. And click on the bell icon so that you can get latest notification of our lectures, guys. And our channel on the Telegram app is by name JEE_English, and link for this channel is given in the description part of this video. Now guys, let me tell you the simple steps through which you can subscribe to Unacademy. Just go to Play Store and download Unacademy's learning app and install it. And after installing it, guys, click on the plus, and once you click the plus, just check the IIT JEE box, and then you hit that subscription button. Once you are hitting the subscription button, guys, then you will be reaching onto this page, and on this page, guys, for 24 month, guys, if you are applying my code, you have to pay 50,000 rupees. Now let me tell you the fee structure, guys. For 1 year the fee structure is like it, for 2 years the fee structure is like it. But if you are applying my code Rahul Cam, then instead of 38k you have to pay 34k, and instead of 56k you have to pay 50k. Okay, guys. So I'm telling you, keep this thing in mind. Rahul Cam, this is my code, guys. And once you have subscribed to Unacademy, guys, you will get a structured course there. After every class you will get a DPP. After every class you will get module. Then your course would be structured. Every week you will have weekly quiz, and once your topic is over, guys, once your topic is over, then you will have a mega quiz. You will also have access to the test series conducted by Unacademy, and along with test series, guys, you will also be having access to video lecture and content of all the educators. Right? Suppose you have chosen the IIT JEE, then you will have access to physics, chemistry, and math content of all the educators, live as well as recorded. So guys, this is all for today, guys, and I hope you enjoyed today's class. Thank you, guys. I will meet you again at 8 p.m. Today I will be discussing